Our project is about predicting breast cancer cells, and our team members are Mildred, Alexandra, and Claire. So breast cancer is very common among female. There are more than 200,000 diagnosed cases and 40,000 deaths in women per year in the US. We are interested in the topic because we believe the breakthrough of technology in medical field support human in future survival. Our data source is Breast Cancer Wisconsin dataset from Kaggle. It has 32 attributes, including ID, target variables, benign and malignant for diagnosed results, and other real-valued features. Past references are 2 research articles. Many models on Kaggle focus on accuracy but not recall. Our goal is to maximize the recall rates because the false negatives are costly in our case. For our project, we will test out different models like decision tree, KNN, and logistics regression, and refine the models with the best results.
Our process outline includes data preprocessing, feature selection, compare models, and analyze results. Since our problem is a classification problem, we use the 3 classification models. First, we do data preprocessing. We clean the data set, dropping ID and unnamed columns since they are irrelative to our goal, and then we convert the target variable value to 0 and 1. We do some data visualizations to understand our data. We split data into train and test sets and normalize it using standard scalar. And last, we have feature selection based on plotting the Pearson correlation matrix. For visualization, the total number of cells labeled is 357 for benign and 212 for malignant, which indicates the target variables are distributed evenly, so we can train both benign case and malignant cases. On the left, the correlation matrix is before dropping features. We first drop the features that have high correlation with other features, and second, we drop the features based on their correlations with target variable. The correlation matrix on the right have all features after dropping.
Now, moving on to the modeling stages. So first, we build the decision tree models, and we test out different parameters in order to find the best model. So here on the top, you can see our some values that we tested for our parameters. Next slide. And on the top here, we can see the optimal parameters that we got from running the model. It's as follows. So we use entropy and maximum depth of 3, minimum leaf sample of 11. This is our optimal set. And here below, the confusion matrix, accuracy, recalls are what we get from our test data and our predictions. Next, we build our KNN models. As before, we also test different K values to find the best one. And on the top, the K list indicates all the K values we tested for our model. Here we found the optimal K to be 3, and below are the confusion matrix, accuracy, and recall for our test data and our predictions. Lastly, we also create a logistic regression model. So we use the training data to fit the model and make our prediction. Here, as usual, is our confusion matrix, accuracy, and result for testing for the test data and our prediction. Putting everything together, here are the accuracy rates, false negative counts, and recall rate for each of the model. Comparing all the 3 models, we can see the KN model produced the highest accuracy rate, which is the 96.49%. However, it does not have the highest recall rate and the minimum false negative counts. As mentioned earlier, our goal is to maximize the recall and minimize the false negative. So the logistic regression is the winner here because it has the highest recall rate among the free model and the least number of false negative cons among the free. And this is our presentation. Thank you so much.